Okay, this is the instructions. Go ahead and first answer the claim, evidence, and reasoning. Read through that. It's basically your educated guess as to what's going to happen. We're not doing like a candle and wood. We are just focusing on different types of chips. Basically, you need a 3 by 3 inch square of aluminum foil. It doesn't have to be exact, but just measure that out. It's basically what you're going to be burning the stuff on. So you're going to measure that, the combined mass of the aluminum foil and the and your chip. Let's see, do we have paper clips? Then you're going to use the graduated cylinder and fill it to 50 milliliters of water. That's that right there. You're going to bend the tab up from the soda can and then use these wooden sticks. It says glass. The wood is better because it doesn't break. Put it through the tab of the cans and then through the ring stand, as you can see right there, and it'll hold up. I'll do that as an example. So let me grab this. There's the ring stand. There it is with the soda can. You see how that works? Pretty simple, right? This is a little high. You want to lower it down to where it's about an inch above. You want the flame like directly on the bottom of the can. So I'm going to lower it down quite a bit. That's probably good right there. This is where this is gonna be full of 50 milliliters of water. You pour the 50 milliliter water into the top of the Coke can, just like that. See, there we go, 50 milliliters of water. Put that bad boy in the Coke can. Get it all in there. Maybe better than I did. All right, now you're gonna plug the scale in to the wall. Turn it on. You'll see that it doesn't read exactly 0. You're gonna hit 0. So basically, what you're gonna be recording is the initial mass and the final mass of the chip, and then subtracting these two so that you get the change, the delta mass of the like I said, you can cross out candle, wood, and just put the different types of chips in there. Mass of water, that's going to be fixed at 50 grams. The initial temperature, you need a thermometer. Basically stick the thermometer in the can. Be careful with these, you break it. You basically got a glass mess. You want to read the thermometer at the same, you want to be level with the red liquid in the thermometer in order to read it. So this is 20 degrees Celsius. So you'd put right there 20 degrees Celsius. Final temperature, that's after basically all the chip, as much of the chip is burned up. And I'll show you that here in a second. Okay, so make sure when you weigh the chip, it's not touching the outside edge of the scale, because it's not gonna read correctly. So you might want to make this more of into a cup as much as you can. That'll help keep the mess down. So notice, oh, it's still touching. So this piece of chip with the tinfoil is 1.35 grams. So I could write here on my table let's go ahead and write some of this data here. So initial mass 1.35, and we also have initial temperature 20 degrees Celsius. Okay. I'm also going to kind of hang the piece of chip a little bit over the foil and make sure there's kind of a gap for air to get in there so it'll burn better. Okay, so let's give it a shot. Okay. Just like that. Looks like we have a burning chip. Put that under the can like that. I want as much the fire to go on the can as much as possible. That's looking pretty good. And if we look at the temperature, there's already a little bit of change in temperature. Oh, it went out. You want to act quickly and get it lit again. Okay, we miraculously got it lit again. You might want to move the ring stand so that it catches as much heat as possible. Okay, you know what? It went out, but we might have enough to do this calculation. We see that the temperature is now 35, 36, 37. Sorry, 27 degrees Celsius. So let's go ahead and bring the chip over. You don't have to burn the whole chip up. Notice it's a little bit lighter. 1.23. Now we got enough information to do a calculation. 27. So our delta T is going to be 7. Mass of water was 50. The change in the mass of the Dorito, I could do that in my head. That's 0.13. Sorry, 12. And that's pretty much it, folks. And you just do your Q, MC, delta T calculations, and then to get the density, the energy density, you're going to divide by the change in mass. So you're going to carry this information down here, the mass of the water. This is for your MC delta T calculation. Specific heat of water, this is always going to be the same. And delta T was 7. And then you can calculate the energy. Okay, so there we go. So 50 times 4.184 times 7. How many joules is that? That's 1,464 joules. Then we come down here and calculate heat density. So this was, the first one was our Dorito. I just got the orders mixed up. So that's a Dorito. Q is 1,464. The delta mass, it was tiny, it was 0.12, but we didn't burn the whole chip. So then divide these two. 0.12 equals 12,203. And if you want to know the calories per gram, it would be, you would divide by 4,184. And so I got 2.91 calories per gram, or 2.92 calories per gram. That's not too bad. That's about half efficient, but remember the match was burning under there too, so that might introduce some error. So those are some things to think about. Good luck.